And now we're going to go all the way here, from here, the Middle East, to Middle Earth. That's right, Tolkien's Middle Earth. So our next talk is about one device to rule them all. It is inspired by Tolkien. Our next speaker, please give it up to him, is a first-time speaker on the BSidesTLV stage. This is Elad Ernst, everybody. Yeah, and Elad has just come back from New Zealand, aka Middle Earth, the land of Tolkien and hobbits, and he's going to talk to us about one device to rule them all. All right, you ready to go, Elad?
Yes.
The stage is yours. Let's give it up for him one more time. First-time speakers. That's what we love here. Yes, Elad, thank you.
So, hi everyone, thank you for coming. I'm going to speak on a very cool vulnerability we found that affects thousands of IoT devices around the world. But before we begin, so shortly about me, I'm Elad Ernst, I'm a security researcher. Actually, I'm second generation of security researcher. My father, which also sits here, is also a security researcher. As he always say, the more devices you exploit, the less floor you have to wash. So this is me. And before we start, a short motivation. So if I'm an attacker and I want to penetrate into an organizational network, so in the classic work, there were some very common vectors. So if we will take a look on these vectors, so the most common was trying to exploit application in the DMZ, for example, and then get from there into the network. Another one was using client vulnerabilities, for example, Chrome vulnerabilities or Office vulnerabilities. Another one was using mail attachments, sending eggs in a mail or something like that. Another common one was using phishing and stealing credentials, and then they use it for connecting to the VPN or the server of the company. So if you take a look on all these vectors in the current world, all these vectors became much less relevant. And each one for its reason, but for example, if we take the DMZ, so DMZ almost disappeared. Most of the application migrated to the cloud, and DMZ became very irrelevant in this world. Current vulnerabilities still existing, much harder to find, much harder to exploit, and very expensive. Mail attachment, so almost any organization today has a system for mail filtering to prevent this kind of attacks. And phishing, as we saw in the last presentation, it's much more less relevant today because of the common of MFA mechanism. So actually, this type of attacks still possible, but much more harder. If, from the other side, we'll take a look on what's happening in the IoT world, so the amount of the IoT devices increased drastically. Most of the IoT devices still very insecure. The amount also increased in the organization network. For example, IP phones, smart TVs, conference room systems. Most of the IoT devices still very insecure, and still almost no one cares about the security of IoT devices. And all these things make IoT devices very, very, very attractive attack vector for attacker. What's the problem? The challenge is for the attacker is that IoT devices, most of the time, not accessible directly from the internet, but they're behind firewall, behind NAT, and they're not accessible directly from the internet. So this is one of the things we try to exploit in our research. So let's talk about our research. So the goal of our research was basically to find a remote code execution vulnerability on IoT devices. But we want to find a vulnerability that is cloud-to-device vulnerability. What it means? It means that a vulnerability that we'll be able to exploit without being accessible to the device, but exploiting the issue that the devices communicate with cloud services. So we want to actually be able to exploit a device without having direct access to the devices. So as a target, we chose a very big OEM. So it's very important to understand what is OEM, because it's a very common thing in the IoT world. So actually, if you take a look around you on IoT devices, most of them didn't manufactured by the vendor who branded. Sorry. Most of the IoT devices didn't manufactured by the brand that the name is on the IoT device. Most of them actually manufactured in China by a Chinese company and sold to other branded inventors around the world. Why it is interesting? Because if we will be able to find vulnerability in an IoT device, and the vulnerability is part of the software of the OEM, so it might be affect all the vendors that buy devices from this OEM. So this is a very nice thing. So this is our target. And from this point, we started our research. So we went into Amazon, and we ordered a very generic IoT device, very generic Android device of this vendor. And we started to explore the device to understand what's going on. This Android device is mainly used for smart TV, for streamer, and other stuff. And we started to explore the device, and we found out that there is outgoing communication from the device in TCP port 8883, which usually stands for MQTT over TLS. So what is MQTT? So MQTT is a very common protocol in IoT world. It should be very lightweight. And it's basically contains three main entities. The first one is the broker, the second one is the client, and the last one is the application server. So the broker. The broker is just an applicative router. It's just taking the data, transferring the message between the clients and the application server. It's not doing anything by itself except transferring the data. Usually, the broker will be cloud in the server cloud. It can be also managed services. Google have their service, Amazon have their service. And usually, it will listen on TCP port 18883, or in our case, if it's MQTT over TLS, on 8883. And it's very important to remember that the broker is not the applicative server. There's another application server which also communicates with the broker. The broker just transmitting the data between the clients to the application server. Okay, the data in the broker organized in something that's called topics. What is topics? So basically, think on newsletter that has many sub-magazines. For example, he had food magazine, he had fashion magazine, and each magazine has sub-magazine. For example, Israeli food magazine, Asian food magazine. If I can do subscription to all of the newsletter magazines, I can ask to subscribe just for the food magazine, can ask to subscribe just to the Israeli food magazine. So this is basically topics. Of course, the topics is just the name of the topics, not the content. Like in newsletter, it's not the articles. And we'll see example soon. So, as I said, topics hierarchical. I mean, I can have a further topic, another topic. For example, a classic MQTT broker will have a app topic, and that will be able to have devices topic, and that will be able a topic for each device, and for each device we can have subtopics. This is the name of the topics. Under each topics we can have data. We'll see how it works in the next slide. So this is topics, and the other entity we have in MQTT is the client, which usually it's the devices. It can be other things, but usually it's the devices. And they communicate with the broker on TCP. They initiating the connection to the TCP port. And they can basically do two main things. They can publish topics. They can publish data to topics. And they can subscribe to topics. They can ask the broker, if someone publish data to this topic, give it to me. It's very important to remember that the TCP connection between the clients and the broker is always open. That's why the client cannot speak with the broker for a lot of time, but if the client subscribes to some topic, and after 2 hours someone published data to this topic, the broker will be able to push this data to the client, even the client is behind NAT or behind firewall. So this is the client. And the last entity we said is the app server, which actually it's just another client. It's connected to a broker in the same port, communicate in the same, can publish, subscribe, etc. So this is the basic of MQTT that you should know for this talk. Another important thing is the wildcard. So the wildcard, it basically lets the clients to subscribe not to specific topics, but to topic and all its subtopics. For example, if you have these topics, app/device/device1/logs and other topics, if someone will subscribe to app/devices, it will receive messages that publish to all its subtopics. So this is very useful and very common. Great. So this is the basic of MQTT. Let's talk a little bit about the security of MQTT. So basically, MQTT is not encrypted, but it can be encrypted, like we have in our case, MQTT over TLS, if it's supported by the broker, of course. Authentication. So MQTT basically supports two main authentication mechanisms. The first one is username and password. The second one is client certificate, which, of course, available just if we use MQTT over TLS. Authorization. So the authorization of MQTT based on ACL that should be defined on the broker by the manager of the broker. And the ACL is very simple. They can say which client can publish to which topics and which client can subscribe to which topics. This is the basic authorization mechanism. Of course, this good authorization can be achieved just if we have good authentication mechanism, because otherwise we can't differentiate between clients. Okay, this is MQTT. Let's go back to our research. So we have our device. We saw the MQTT communication. We want to start to understand what is this communication. So we had a ADB connection to the device. We connected the device with ADB. And we found out the APK that actually creating the MQTT connection. We extract the APK and trying to decompile it. And started to decompile it, and we actually found out hard-coded credentials in the APK, which is very nice. It's username and password. And the cool thing is that if you think about it, if they use hard-coded credentials in the APK, probably it's the same credentials for the devices, which means probably they don't have good ACLs on the broker. But let's check it. So we have hard-coded credentials. We want to try to connect the broker. So the next thing we'll do, we'll try to use our client to connect the broker. So for these things, we use a tool that's called MQTT Explorer, which is a very useful tool. It's a GUI, just GUI client for MQTT. We try the credentials to connect to the broker. Then we insert the credentials, and actually it's worked. So we are now connected to the broker, but we want to see something. So we ask from the broker to subscribe to wildcard. It means give me all the data that everyone sent to any topic. So we send a subscribe message to the broker, and it's worked, and we started to receive data, which is very cool. So what can we see here? So actually, we can see a lot of topics that created by many devices, a lot of devices of many different vendors. I mean, this MQTT broker is owned by the OEM, and there is data of many devices that sold to many different vendors. And for each device, we can see a lot of interesting things. For example, we can see the internal IP of the device, we can see the external IP of the device, the Wi-Fi name, the geolocation, and a lot of interesting things. This is metadata message that each device sends every few minutes, like a keep alive message. So we can see a lot of data of, let's do a short summary. We can write credentials for the MQTT broker. We can connect to the broker. We can actually subscribe, we can actually subscribe to wildcard, and we can see data of thousands of devices around the world. The next thing we want to do, of course, is trying to not just passively watching data of other device, but also be able to send and influence other devices. So we went back to the APK, and we tried to find where is the function that handles the messages that came from the broker to the client. So we found the function, and actually it's very funny, but we found a full CNC switch case, which is very cool. What's happening is that the device is supporting to get messages from, it's supposed to be from the application server, but actually, we will see if everyone do it. But there's a type of message that's called task. There are many nice tasks, for example, taking screenshot, taking deal list, and of course, the cherry of the top, there is shell task. So now we want to check if we can publish messages to other devices, because these handlers exist, but it does not mean that we have a permission to submit messages to other devices. So we created a very simple task message that's basically creating a screenshot and upload it to our server with CURL. So we created a message, we sent the message to other device, and we got a screenshot. It's very cool. It's very cool. We can run code on other devices. We can take screenshot. But the next question is, would we be able to do it not for just one device, but to many devices. Let's say to all the devices that we can see. So, of course, why not? We created a very simple Python script that will do it. And we ran the script, and it's worked. We started to get screenshots. And it's very cool, because we started to see the screenshot, and there are very, very many types of screenshots, some of them from private homes, some of them from hospitals, some of them from banks, some of them from private companies, conference room, other smart TVs, many, many, many different systems, which is very cool. And now we have a lot of screenshots, and we have something interesting to do with them. So what we did is created a collage of BSidesTLV. So yeah, which is very cool. But the question is, what's next? So we actually have screenshots from a lot of devices. We have metadata from a lot of devices. And we started to investigate from what is these devices, what they use for, where they are located. We have the external IP of devices. We have screenshot. We have the Wi-Fi name. So we started to work and found out that the device is located in very big hospitals, in very big companies, in stores, mainly used for digital signs. Also, of course, in a lot of private houses, but all around the world, it's very crazy. And we started to think, okay, we can run code on devices. We are not accessible to these devices directly, but we can run code on these devices. So maybe we can leverage these devices to get into the networks they are in. So, of course, we didn't did this step, but this is the ideas we had. So we are sitting on the device. We have a leg in the LAN. Of course, the first thing that we can do is do very basic LAN attacks, responder, etc., and other types of LAN attacks. We can also, if we have, for example, we can run code on Smart TV, we can ask from the user to download a driver if you want to cast something from our to our TV, and then we can run code on this laptop. Or, for example, if a user wants to get into a Zoom meeting or Google Meet, we can ask credentials, they will give it to us. But the question is, okay, we can run code on these devices, but let's say that as an attacker, we don't want that our IoT devices will start to behave strange. What does it mean? It means most of the IoT devices usually communicate with the same servers. If I will ask from the other device to download my tool from another server, it will look strange in the external firewall of the organization. So what we actually did is we encode our tool with base 64 and just send a lot of shell tasks and writing the tool to the device using the base 64 built-in on the device. And then what we did is created a very simple tunneling tool that can let us do TCP over MQTT. Because this is very easy to do it on MQTT, because as I said, the broker is just a applicative router. It doesn't care about the data that's going through it. So I can actually just put a client that's sending message to, converting message from TCP to MQTT, and on the other side the same, and we have tunneling tool over the MQTT broker. That's why even if someone will look on the external firewall, the device will behave exactly the same. So this is mainly the research. Let's talk shortly about the disclosure process. So we found the vulnerability about a year ago. We tried to contact the OEM in any available media, mail, LinkedIn, Facebook, Instagram, TikTok, Snapchat, Tinder. I'm kidding, of course. They didn't respond yet until this time. Possible reason. So the possible reason is it's funny. There is new law of the Chinese government that started on 2021 that basically say that if hacker want to talk with a Chinese company and tell them that he found a vulnerability, you need to speak first with the Chinese government, which basically says that the Chinese government collects 0 days for all of our devices, which is very scary. We do reach some of the clients directly and help them to solve this issue. So this is the basic. Short summary, so very cool new attack vector. I think we'll see a lot from this attack vector in the coming few years. Actually, IT devices still very insecure. Almost all of them speak with the cloud. Very interesting thing to do. Actually, it might be Chinese vector, and it's very scary because most of the IT devices we have today made in China. For IT vendors, so check what do you have in your devices that you got from the OEM. And for CISOs, it doesn't make sense that you will think or you know about IoT devices different from your PCs. They can be attacked, they can be entrance to your network. Start thinking about them like PCs, antivirus, manage them, other things. So any question? No, so I just want to thank you all. Thank my wife, amazing wife that helped me with that. And hope you enjoyed. Thank you.
Thank you, Elad. Thank you, Elad. Thank you all the way from Middle Earth right here to the Middle East.